short, in shorthand, short writing, okay, you can write it this way. This is a question mark, okay? It's a question mark. So let's do that. Earlier, what you saw is what? F inverse and this and F inverse this both have to be X, okay? So in order to say G is F inverse, we are going to compose F and G, and then the result has to be X, okay? So first one is I'm going to compose F and G in this order, okay? So what does that mean, everybody? Composition. That is, F is the main one and the G goes in there. So what is that? F of G of X is 1/2 X minus 5. So let's pause. What does that mean? Yes, now the function G, F has input like 1/2 X minus 5. And then go back to here. What does function F do? It doubles the input and then add 5, correct? Okay? Sometimes it's like describing verbally rather than just 2x plus 5. Double the input and then add 5. That helps. So double the input. Input is this, 1/2 X minus 5, and then add 5, correct? So let's multiply out. You multiply out, that gives you X minus 10 plus 5, which is X minus 5. Oops, what do you want to see? If you want to say this is inverse, you want to see just X, but it's X minus 5. So it's already, we can say, no, G and F inverse, yeah, G is not F inverse. We can say that at this point. However, just for the sake of argument, I'm going to just continue, okay? G circle F of X. So that means G of F of X. That means G is a main function, F goes inside. So F is 2x plus 5. So now go back to function G. What does function G do? It halves the input and then subtract 5. So halves the input. So 1/2 times 2x plus 5, the input, and then subtract 5. So you distribute over here, so x, and then plus 5 halves minus 5. Anyhow, this is already, again, it's not x, okay? And this is not x. So we tried in both ways, well, it doesn't work, okay? So this is not, G is not inverse function of f, okay? So this is how you, if they give you two functions and then determine if one is inverse of the other, this is what you need to show. And you want to see x. In both ways, you want to see x in order to say, yes, they are inverse of each other. Okay? By the definition of inverse function, the input of f is the output of f inverse, and the output of f is the input of f inverse. So collectively, f and f inverse, everything is just interchanged, x and y. So input of f becomes what? Output of this, f inverse. And the other around also, okay? The other around. So either way, input, output, so that means x and y, they are just swapped. That is the definition of inverse function. So example 4, finding inverses of a one-to-one function. Find the inverse of this function that is one-to-one. Okay, so let's see. This relation G says this, -1 to 0, 1, 1, 2. I said just relation because I'm not sure even this is a function. Function means no repeating x values. -2, -1, 0, 1, 2. All different x values. So yes, this is a function. Check. Is this a one-to-one? One-to-one means, yeah, we verified that all the inputs are all different. That means the outputs are all different also. Okay? You should not see any repeats in y values. 5, 2, 1, 2, 5. Oh, is it one-to-one? No. Two different y values over here. Yeah, two different x values, -2 and +2, they have the same y value. So this is not. Therefore, no inverse. Okay? There is no inverse of that. But there is, I'm going to make another one. Okay? There is a margin. So let's make another thing. So let's make it H. 1, 3, 2, 6, and 3, 8. Okay. Is this a function? Yes. No repeats in x values. So yes. Is it one-to-one? All different y values. So check mark. Okay. Then we can find the inverse. So let's find the inverse. What is that? Yeah. Do not make it too complicated. What do? You swap x and y coordinate. So 3, 1, 6, 2, 8, 3. That's the inverse function of h. Isn't that simple? Okay. So when you have a function has a look like this, just the collection of those relations. Yes, it's a very, very easy thing. But do not say the function is not one-to-one. No, you cannot have an inverse. So now, this is the main part of today's lecture. That is, let's find the inverse function. Just, algebraically. So the focus for main part is how to find F inverse. Okay? How to find F inverse. So that means the function is already one-to-one. Okay? That part is given. So you have what is given over here is that f of x. Yeah. You can say that is y. Correct? So the first part is that, okay, use y. So instead of f of x, use y. Okay, y to replace f of x. And the second part is going to be, so once you have a y, and then you are going to, change x and y. So in short, x and y, you swap. That's all. And the third step is, so far there's nothing, no significant here. Okay, nothing significant. Just do this. And then the third part is now solve for y. Okay, those 1, 2, 3 steps. Okay. Example 5. Again, this is one-to-one. Okay, that part is given. Here, function a is f of x equals the absolute value of x, and they decide whether each function defines a one-to-one function. If so, find the equation of the inverse. Well, is this a one-to-one function? Does anybody know the graph? Yeah, look at the graph. Oh, V. It's not good. One portion decreasing, increasing. Or you may say 3 and -3, two different input, but the output is the same 3, correct? Okay, so this is not 1 to 1, therefore game over. Okay, you don't have to play any other thing. B is g of x equals 4x minus 7. Okay. Alright, so g of x equals 4x minus 7. Okay. What do? Use y to replace f of x. So in this case, g of x. So in other words, first step, you use y, 4x minus 7. What about the second step? Interchange x and y. Oh, that's a piece of cake. X, 4y minus 7. And this, you call it what? F inverse. Okay? And the third step is what? Solve for y. So we need to leave y by itself. So in order to do that, add 7 to both sides. So make it what? 4y equals x plus 7. Now y equals x plus 7 over 4, or you may say x over 4 plus 7 over 4. And once you solve for y, yes, you name it, this is g inverse. Okay, I'm going to try to graph these two things. So, g of x is 4x minus 7. So, y-intercept is negative 7, slope is 4. Slope is pretty stiff. So, when x equals 1 is negative 3. When x equals 1, negative 3. So this is g of x. Okay. What about g inverse? G inverse has a slope 1. So this is the same as, okay, g inverse. I'm going to separate this so that 1/4 x plus 7 over 4. Slope is just 1/4 and the y-intercept is 7 over 4. Just a little less than 2. Okay? And the slope is 1/4, so it's very moderate growth like this. Okay? So this red one is g inverse. Blue one is g of x. So first I want you to notice that if function is a straight line, the inverse function has the slope that is the reciprocal. If this is 4, it's 1/4. If this is 1/2, it would be 2 over here. Okay? And another thing is, this graph, well, is there any symmetry? That's a big question also. Yes, there is a symmetry, but this symmetry is nothing that you saw now here. The symmetry is, the line of symmetry is the graph y equals x. So that is like a big diagonal for the whole thing over here, big diagonal over here, y equals x. And these two graphs are symmetric about this line, y equals x. Is it the only case like this, just coincidentally? Well, that's not it. Always, when you have a graph of a function and its graph of its inverse, those two graphs will be symmetric about the line y equals x. Okay? And in particular, here, when you have a straight line, the slopes are the reciprocals. The next one, h of x equals x cubed plus 5. So let's see. X x cubed plus 5. Is this one-to-one? Do you remember the graph of x squared? When you have y equals x cubed, it goes through the origin and increasing all the time. Yes, increasing all the time. But you have a plus 5 in the back. So what does that mean? That means it is like when x equals 0, here y equals 0. On the other hand, when x equals 0 here, the y value is going to be 5. So 5 up here, so it has like a shifting up 5 units. Exactly the same shape, okay? Exactly the same shape, but it's moved up, okay, by 5 units. Okay, that's it. So therefore, well, this graph shows that this is one-to-one. Yes, one-to-one, check mark. So now we can compute the H inverse. So what is the first step? Bring in y. So instead of h of x, you are going to put it y equals x cubed plus 5. The second step, you are going to swap x and y. So x equals y cubed plus 5. So far so good? Well, step 3, you are going to solve for y. So before you go to y, you have to leave y cubed by itself. So subtract 5 from both sides and make it y cubed equals x minus 5. So y cubed equals x minus 5. What we want is y, not y cubed. So how can you find the y over here? Yes, you are going to take a cube root, okay? Take a cube root, so cube root of x minus 5. Okay? And you name it H inverse. So H inverse is this, cube root of x minus 5. Okay, so what does the graph look like? Okay, earlier I said no exceptions. All the functions have, if they have an inverse, the graph of a function itself and the graph of the inverse function, those two graphs are symmetric about the line y equals x. So here is y equals x. Okay, so this is y equals x, so this is a line of symmetry. And yeah, let's graph H inverse. Do you remember that cube root of x graph was like this? In fact, y equals x cubed and this, they have the same shape. X cubed is stretched vertically, and y equals cube root of x is stretched horizontally. Okay, and again here x minus 5, in that case you are going to shift this one to 5 units to the right. Okay, so 5 units to the right, and the graph looks like this. Okay, so graph like this. Okay, so as you see, it looks like a vase over here. This red curve is the original function h of x, and this blue curve is h inverse. Okay, so they are symmetric about this line y equals x. And another thing very clear is that when you find the inverse function, what did we do? We swapped x and y coordinate, right? So that one has to be reflected on the graph. So look at this point, 5. That means what? 0, 5, correct? What is the corresponding point across this line of symmetry? It goes over here. Yes, this 5 means 5, 0. I mean, literally, you just interchange x and y coordinate, and then you can find the graph of the inverse function. Okay, so 0, 5 goes to 5, 0. Yes. Okay, so for example, over here, some other point, just if you have this, this one will go over here. Okay. All right. Oh, let's do just one thing. Let's verify one thing. Earlier, h of x equals what? X cubed plus 5. And then we found that h inverse is a cube root of x minus 5. Let's compose and then verify that. Okay? Let's compose just one thing. Okay? H and h inverse. We are going to compose it. So h inverse goes to in here. So what does that mean? H inverse is cube root of x minus 5. Okay, here we go. What does h do? H does cube the input and then add 5. Is that right? Cube the input and then add 5. So cube the input. Input is this. So cube root of x minus 5 will be cubed and then add 5. That's what h does. So here we go. Cube and the cube root cancels. Now you have x minus 5 plus 5. Okay. Plus 5 minus 5 cancels. So this is x. Yes, this is what's happening over here. No exceptions. Okay. Once we compute the inverse function, this is one way to verify that what you did is right. Okay. I'm using microphone, but for today, I didn't really feel well this morning, so I cannot really speak as loudly as I used to. So, I don't know. You may have to really just volume up a little bit, okay? Oh, example 6, that's what you did. Oh, we already did, okay? 4x minus 7, yes, 1/4 of that. Okay, let's do example 7. Example 7 over here, you have f of x equals minus 3x plus 1 over x minus 5. Of course, the denominator cannot be 0, x cannot be 5 over here, okay? Is 1 to 1, find its inverse. It already says this is 1 to 1, so find the f inverse, okay? So, find f inverse. So very first thing you need to do, yes, this is the kind of as complicated as it gets, okay? So here, the first step, yes, instead of f of x, we use y, okay? So make it just simple. Y equals negative 3x plus 1 over x minus 5. And the second step, you swap x and y, but there are two x's, correct? So x equals, that means you are going to see two y's over here. Y minus 5